So welcome back to Make Mechatronics. This is the first video in the series. ओके सो आज हम लोग बात करेंगे एक बहुत ही बेसिक सा कॉमन सा इलेक्ट्रॉनिक कंपोनेंट जो कि ऑलमोस्ट हर जगह यूज़ होता है. ओके सो दिस इज़ द ऑसम कंपोनेंट कॉल्ड 555 टाइमर आईसी. नाउ व्हाट इज़ अ टाइमर फर्स्ट ऑफ ऑल. सो जितने भी कंट्रोलर सर्किट्स होते हैं, जितने भी कंट्रोलर सर्किट्स का मतलब होता है कि जितने भी माइक्रो कंट्रोलर सर्किट्स होते हैं उनके अंदर एक छोटा सा एक कंपोनेंट होता है, देयर हार्ट बीट, द ऑसिलेटर. ओके, ऑसिलेटर इज नथिंग, इट जस्ट गिव्स आउट स्क्वायर वेव आउटपुट. बट जितने भी हमारे डिजिटल सर्किट्स हैं, जितने भी हमारे सिक्वेंशियल सर्किट्स हैं, वो उसी स्क्वायर वेव आउटपुट को एज अ क्लॉक सिग्नल लेते हैं एंड उसी पे सब कुछ चलता है ऑलमोस्ट. And this 555 timer can be used to generate that clock signal. Most of the microcontrollers nowadays use the crystal oscillator because it's much faster than 555 timer IC, but this is a very important component. That's why we are going to study in detail that what this component is, okay, and how it is useful, and what are the internal structures which makes it to generate that 555 that generate that square wave. Okay, and also what are the applications of this. So first we will start with the structure of it. So let me load the structure. Okay, so this is a structure. It is drawn by a famous YouTuber, Ben Meter. Okay, so I'm using this to explain. So in this structure we can see that the purple box here is which denotes the 555 timer ICs. Okay, and all the things outside it, it is not like the part of 555 timer IC. It has to be connected externally, and what is inside the purple box is inside the timer IC. Okay, now the first thing is this line, which is first it's connected to 5 volt, and उसके अंदर पहला component एक resistor है which is 5 kilo ohms. Second component is a resistor which is 5 kilo ohms, and third component is a resistor which is 5 kilo ohms. Now I know that all of you are thinking that, oh, that's why it is called 555 timer, because it has three resistors connected in series of 5 kilo ohm, 5 kilo ohm and 5 kilo ohm each. But no, that's not the case. Okay, it is a mere coincidence. Okay, it happens. So not exactly I know what is the reason, because as per the name, but this is not the reason that I know. Okay, so let's move on. So this 555 kilo ohm resistor divides the 5 volt and the grounds into two equals. Okay, we're going to learn about potential dividers in next circuit, but let's see. We all know that if there's a resistor 5 kilo ohm, 5 kilo ohm, 5 kilo ohm, the amount of current will be 5 volt divided by 15,000 ohms, because it's in series. तो हम तीनों रजिस्टर को ऐड कर देंगे एंड डिवाइड कर देंगे 5 वोल्ट से. सो हमें करंट मिल जाएगा, एंड एक बार करंट मिल गया तो हम वोल्टेज ड्रॉप निकाल सकते हैं. तो फर्स्ट रजिस्टर के अक्रॉस वोल्टेज ड्रॉप को अगर 5 वोल्ट से माइनस कर देंगे तो यहाँ इस पॉइंट पे जो वोल्टेज आएगा विच विल बी 3.33 वोल्ट. सेकेंड रजिस्टर के अक्रॉस जो वोल्टेज ड्रॉप होगा उसके बाद जो ये पॉइंट पे वोल्टेज रहेगा इज 1.67 वोल्ट्स, एंड थर्ड रजिस्टर के बाद कंप्लीट वोल्टेज ड्रॉप हो जाएगा 0 वोल्ट तक. ओके, लेट मी रिपीट अगेन. जो पहला रजिस्टर है यहाँ पे, ओके, उसके अक्रॉस कुछ वोल्टेज ड्रॉप होगा, लेट इट बी एक्स. तो वो इतना वोल्टेज ड्रॉप हो गया. ओके, इतना वोल्टेज ड्रॉप हो गया तो कितना वोल्ट रहेगा वहाँ पे? 5 माइनस एक्स, so that is 3.33. Then another some amount of x will be dropped across this second resistor 5 kilo ohm. Okay, so that is 1.67. Okay, after dropping, so 5 minus x is 3.33, 5 minus x is 1.67, and 5 minus x minus x minus x is equal to 0. That means x is 5 by 3, right? Okay, so that's about the maths. So all you need to know is the voltage at between this resistor is 3.3 volts, and voltage between this and this is 1.67. Now let's take a tour of all the components. Okay, these resistors we already talked about. This some of you guys will know that this is a bipolar junction transistor. Okay, or maybe a different transistor, just a transistor, we don't know it. Okay, so by the look of the diagram, you can see it's a transistor. Okay, where the collector is connected to the pin number 7 and the emitter pin is connected to the ground, and base is connected to a SR latch, something called SR latch, and it base of the transistor is connected to the Q, and above Q there's a dash. So what is this SR latch? Now SR latch, okay, it's a digital component. What it does, that it's simply, let's simply explain it. So we have two inputs, S and R. Okay, S and R. If I give S1 R0, now what is this 1 and 0? Okay, so 1 means 5 volts and 0 means 0 volts in simple language. So if I give S1 R0, this SR latch is in a set configuration. Okay, let's see, explain, let's this is the SR latch. It's just to which gate this is, can you guess? This is a OR gate with a bubble on top of it. So what do you call this? Okay, let me know in the comments. So this is the SR latch. Okay, and we can see the output is Q and the another output is P. So P here comprises of our Q bar. The dash above the Q is called Q bar. Okay, now what this SR latch does is, when S is 1, R is 0, then Q bar is 0 and Q is 1. When R is 1 and S is 0, then opposite, Q bar is 1, okay, and Q is 0. If S and R both are 0, that means hold output, means whatever the previous output was, it will just hold it, it will not change it. And 1 is invalid input. We can't predict that what going to happen if you give 1. Okay, we cannot predict that either Q is going to be 1 or Q is going to be 0. We can't know. So that's why it's called invalid input. Okay, so this is all the SR latch. In simple language, if you give 1 here, 1 will come out here. If you give 1 here, 1 will come out here. If Q is 1, Q bar will be 0. If Q is 0, Q bar will be 1. These are complement of each other, means opposite of each other. If this will be 1, this will be 0. If this will be 0, this will be 1. Like that. Okay. That's all about the SR latch. Now this triangle thingy. So this triangle thingy is called a voltage comparator. Okay. It compares the two voltage, that the plus sign and the negative sign. Okay, the voltage coming in plus sign and the voltage coming in negative sign, it compares those two voltages and gives output as 1 or 0. In simple terms, we are going to explain it. So if the voltage coming at plus sign is greater than the voltage coming at minus sign, then it is going to output 1. Okay, if the voltage coming at plus sign is smaller than the voltage coming at ground minus sign, then this is going to output 0. समझ गए सबको? जब समझ लो कि यहाँ पे ऊपर 4 वोल्ट आ रहा है, नीचे 5 वोल्ट आ रहा है, सो क्या होगा आउटपुट? गेस. सो अगर ऊपर 4 वोल्ट आ रहा है, नीचे 5 वोल्ट आ रहा है, नो 4 इज स्मॉलर देन 5. ओके, सो माइनस इनपुट इज greater than plus input, so this is going to output 0. नीचे वाला बड़ा है तो 0 मिलेगा, ऊपर वाला बड़ा है तो प्लस मिलेगा. सिंपल. ओके. ओके, so let me just remove this part. okay, so अभी जैसे हम लोगों ने इसको कनेक्ट किया, जैसे हम लोगों ने 555 प्राइमर को पावर से कनेक्ट किया, क्या होगा? As I already said, ये 5 वोल्ट होगा, ये 0 वोल्ट होगा, ये यहाँ पे 3.3 वोल्ट होगा, यहाँ पे 1.67 वोल्ट होगा. ओके, अब ये भी 5 वोल्ट से कनेक्टेड है. 7 जो 7th पिन है वो 1 किलो ओम रजिस्टर से कनेक्टेड है एंड वो भी 5 वोल्ट से कनेक्टेड है. 7th पिन जो है वो 100 किलो ओम के रजिस्टर से कनेक्टेड है एंड वो 100 किलो ओम का रजिस्टर पिन नंबर 6 से कनेक्टेड है. पिन नंबर 6 डायरेक्टली पिन नंबर 2 से कनेक्टेड है एंड पिन नंबर 2 एक कैपेसिटर से कनेक्टेड है जिसका दूसरा एंड ग्राउंड से कनेक्टेड है. This is the all external connections. Okay, so let's imagine at t is equals to 0 what will happen. Okay, so at t is equals to 0, okay, ये कैपेसिटर completely discharged है. Okay, भले ये 5 वोल्ट पे कनेक्टेड है बट अब तक ये चार्ज होना शुरू नहीं हुआ है कैपेसिटर. ठीक है, तो ये डिस्चार्ज है. तो यहाँ पे क्या होगा वोल्टेज, ये इस पॉइंट पे वोल्टेज होगा ज़ीरो. इस पॉइंट पे वोल्टेज क्या होगा ज़ीरो. इस पॉइंट पे वोल्टेज क्या होगा ज़ीरो. बिकॉज एट टी इक्वल्स ज़ीरो द इंस्टेंट यू कनेक्टेड इट टू द पावर. ओके, the instant you connected it to the power, okay, okay, these all voltage will be what, zero, right? Is it going to be zero? Now tell me. You guys think about that, why it is zero and why it is not one. Okay, so let me just change it. Okay guys, sorry for that. So at the starting, okay, everything will be 0 volts. This pin number 6 and pin numbers 2, we just have started, we just have plugged in, so everything will be 0 volts. So let us look at the first comparator, first voltage comparator. So जो प्लस साइड में जो वोल्टेज है वो 0 है एंड जो नेगेटिव साइड में जो वोल्टेज है वो 3.33 वोल्ट्स है. so उसके कौन सा बड़ा है, नेगेटिव वाला बड़ा है. आउटपुट क्या होगा, आउटपुट क्या होगा, नेगेटिव वाला बड़ा होता है तो आउटपुट होता है 0. सो द आर विल गेट आउट इनपुट है, आर विल गेट 0. ओके, देन द सेकेंड कंपैरेटर प्लस, जो प्लस में है वोल्टेज इट इज़ 1.67 एंड जो माइनस में है वो है 0 वोल्ट्स. सो आउटपुट क्या होगा 1. सो नाउ वी नो दैट एट t इज इक्वल्स टू 0, ओके, दिस सेट पिन, दैट s pin is 1. Okay, it is getting output as 1. Okay, sorry, SR latch is getting set input is 1 and R is getting 0. So what happens when we get S equals to 1 and R equals to 0, Q is equals to 1 and Q dash equals to 0, right? I know it's a bit, you have to just stay with me right now. So S is 0, that means S is 1, that means Q is 1. R is 0, that means Q dash is 0. So if Q is 1, this LED is on, output is on. Okay, output is 1. If Q dash is 1, then that means this transistor is off. See, the base of the transistor is connected to the Q dash or Q bar. So transistor is off. Okay, this is the condition at t is equals to 0. Okay, so now if we see a bit forward, okay, the capacitor will start to charge. Okay, the current will flow from here through the 1k, through the 100k, and it will charge the capacitor. As the capacitor charges, at some time, at some moment, its voltage will become more than 1.67, suppose 1.68. Okay, now the negative here, the pin number 2, the negative end of the second comparator is getting 1.68, which is what, greater than positive input, which is 1.67. so this comparator was outputting, previously it was outputting 1. Okay, so now it will output what, 0. So S will become 0. So at this moment S is also 0, R is also 0. So what happens when R and S both are 0? No change, it will hold the previous output. Okay, previous output was what, Q1 Q dash 0, so it will just hold it. Then after some more time, capacitor will charge and it will be more than 3.33 volts. Okay, now when that happens, we will get 3.34, suppose 3.34 volts. So we will get 3.34 volts at plus side and we are getting 3.33 volt at negative side. So the comparator will output 1. So now we have R1 S0, that means Q dash will get 1, Q will get 0, and the LED, the output will get 0. The LED will shut off, okay, or switches off. Now when the Q dash get 1, it will start, it will start the transistor. Okay, or open the transistor gates. So what happens when you start the transistor, now it was charging before, the capacitor was charging, बिफोर इट रीचेस 3.3, बिफोर जैसे जैसे कैपेसिटर जो है वो 3.3 के ऊपर नहीं गया था, जैसे वो 3.3 के नीचे था, ओके, दिस इज 3.3 वोल्ट्स. सो द मोमेंट इट वाज सरपासेस 3.3 वोल्ट्स, जैसे 3.3 वोल्ट उसने क्रॉस किया, वैसे ट्रांजिस्टर ऑन हो गया, ओके, एलईडी ऑफ हो गया, ट्रांजिस्टर ऑन हो गया, एंड वो डिस्चार्ज होने लग गया. दैट मीन्स हाउ इट इज गेटिंग डिस्चार्ज, this is the ground, okay, this capacitor has charge, this is also ground, current from here will go to the ground, current from here will go to the ground, okay, okay. So by this capacitor starts getting discharge. Now at some moment of time it will come below 3.3, okay. So when it comes below 3.3, again this comparator will give output 0. Now again it is 0 and 0. So it will hold the previous output, which was what? Q dash 0, sorry, Q0 and Q dash 1. That was the previous output, right? It will hold that. And then the capacitor discharges more, and it comes below 1.67. The moment the capacitor voltage comes below 1.67, the set pin will get 1, R will get 0, R is getting 0, so polarity switches, Q will get 1 and Q dash will get 0, transistor is off, LED is on again when capacitors will start charging, and this cycle continues, okay. So okay, so like this the 555 timer works. Now what I have explained you is called an astable configuration of 555 timer, okay. There are multiple other configuration of 555 timer, okay, which we will discuss maybe in later stages. So in astable mode, okay, 555 timer, why it is called astable? First of all, now astable means what? That it is not stable in both the stages, okay. There are two states, 0 and 1, and it is going oscillating between 0 and 1 because it is a oscillator, okay. It acts as an oscillator, it gives a clock signal to all the sequential circuits, okay. Now what is the time? Now can we control this on and off timing? Okay, can we? Yes, we can, obviously, because if we are not able to control the on and off timing, then there's no application. I need a faster clock, so I can't make it go fast. So what's the point, right? So in order to control the timing, we have a formula, okay? We have this formula, okay? This says time high, okay? Time high T1. The moment, the amount of time for it, for what? It will be high, it will be 1, is defined by 0.693 multiplied by R1, R2 and C1. Now R1, R2 is resistance of resistor 1, resistor 2, okay. This top one is resistor 1 and this one is resistor 2, and then we have this time low T2, okay. The amount of time it will stay 0 is 0.693 into R2 into C1. Now what is this? Why R1 R2? In for high we are taking both R1 plus R2, and for low time we are only taking R2. Why? Let's see. So by this diagram we can see that the time for it will be high depends on how fast it charges, okay. Because जब तक ये कैपेसिटर चार्ज हो रहा है तब तक ये आउटपुट 1 था, राइट. एंड कैपेसिटर चार्ज हो रहा है कैसे है? वो करंट कैपेसिटर के अंदर जो करंट स्टोर, जो चार्ज स्टोर हो रहा है, इट इज कमिंग थ्रू 1K एंड देन 100K एंड देन कमिंग टू द कैपेसिटर, राइट. तो 1K and 100K both are playing roles in charging. बट जब वो डिस्चार्ज हो रहा है तब सिर्फ 100K के थ्रू डिस्चार्ज हो रहा है, 1K नहीं आ रहा है उसमें बीच में, ओके. दैट्स वाई जो हाई टाइम है, जो आउटपुट का हाई कितनी देर के लिए आउटपुट हाई रहता है, दैट इंक्लूड्स R1 प्लस R2 इंटू C1. बट जो लो टाइम है उसमें बस R2 इंटू C1 है, ओके. सो नाउ वी विल ट्राई टू mimic this circuit in our TinkerCAD. Okay, I know it's been a long video. It has almost been a 20-minute video. Let's quickly make the circuit so we can see in the circuit diagram, this diagram, that we have to connect power ground, which is now, if in TinkerCAD you can find the 555 timer, you can search the 555 value, so you can find this timer. Okay, and how to determine which is pin number one. So for ICs, pin number one is the pin which has the white dot like this. See, नॉच इफ यू इफ द अगर तुम नॉच को अपर साइड में रखोगे, ओके, सो द लेफ्ट मोस्ट पिन, द टॉप लेफ्ट मोस्ट पिन इज पिन नंबर वन, which also usually has a dot. Okay, so you can see pin number 1 has ground and pin number 8 has power. Now how to give power? Now 5 of our timers can take 5 volts, right? So how are we going to give 5 volts to this? We will use the power supply. Okay, we can make our power supply as well. Okay, but we will see that in later stages. So I'll just make the power supply positive. We will give it to power quickly, and then negative we're going to give it to ground. Now we need to arrange the wires. You can also change the color of the wires here so that they are, we are not getting confused between the color, like कहीं और डाल दिया. So then we have pin number 6 directly connected to pin number 2. We will connect pin number 6. This is 1, this is 2, this is 2, connected directly to, this is 2, this is 3, 4, 5 and 6. So it will connect here. Okay, so we will make it blue. Okay, pin number 5 connected, pin number 2 connected to pin number 6. Okay, now pin number 4, it is not given here, but pin number 4 is a reset, and it is an active low reset. Means it, when you will give pin number 4 0, the whole 555 timer will reset, output will be 0, nothing will happen. So we have to attach pin number 4 to power. Okay, which is here, this positive. Okay, I'm going to make it red. Now pin number 6 and pin number 7 are connected through a resistor. Okay, it's a 100k resistor, so let's do that. So we will take a resistor is where, yeah, you can, here there is a resistor, so we place a resistor here. We can rotate it like this. Okay, so resistor we will attach, don't directly attach components. Okay, it sometimes they don't get attached and you will have a connection break. So pin number 7, color blue, then it is connected to pin number 6. Let's make it neat and tidy. Yes, good, all set. Okay, and then we also have to connect pin number 7 to power through a 1k resistor. So we will need one more resistor. Okay, one more resistor, so one more wire from pin number 7, which will go here, and it is going to the power. Okay, so what else we need? We need pin number 2 connected to a capacitor, and which will be connected to ground. And remember that it needs to be a polarized capacitor. Okay, we can't use ceramic capacitors. Okay, positive, negative. So negative will connect to ground as usual. I didn't need to make this big of a connection, like घुमा के इतना, but okay, let it be for now. And then this will get connected to pin number 2. Color is, let's say, purple. I have connected two resistors, one capacitor. Okay. Now, just there's a thing. This we are not using the pin number 5, which is the control voltage. Okay, it has some extra feature. It gives some extra features to the 5 timer. But if you are not using it, we have to attach a 0.01 microfarad capacitor to it. Okay, ceramic capacitor in this case. So we will attach that. Okay. And then the other end of this capacitor will go to ground. Okay, now everything is done. Okay, let's switch it on. Voltage 5, current 5. This is the resistor between 7 and power, so it has to be 1 kilo ohm. It is 1 kilo ohm. This is a resistor between, it has to be 100 kilo ohm. Okay, it has to be, this capacitor needs to be, what, microfarad. Tell me in comments that how much is 0.01 microfarad. Okay, and this capacitor needs to be how much, 1 microfarad. Now this is all done. Okay, it is 1 microfarad only. Now if we start the simulation, let's see what happens. Now, okay, it is giving 5 volt, but what we have not connected yet, we don't have the output, right? So we should connect some output. For output we will use a simple LED. Which color do you guys like? Okay, tell me in the comments. But I like blue color or green, so I will use blue here. Okay, yeah, we also need to attach an LED resistor to an LED. Always don't forget it. Okay, always attach resistor to your LEDs, or else your LEDs will go boom. That means they will die and you will not be able to use them anymore. So let's complete the socket. I know it's not important, but I'm just a guy who likes his circuits, well arranged, wires all straight and all. That's why I'm arranging it a bit. Yeah, blue color. So let's see. So we can see that the LED is blinking, but it is blinking so fast that we're not able to observe it, right? Right? Now let's see. Okay, if we stop the simulation and take our mobile phones, open the calculator in our mobile phones, and let's calculate, do some maths. Now we have, what is our on time? So our on time is 0.693 multiplied by R1 plus R2, which is what, 100,000 ohms, 100,000 ohms and 1,000 ohms. So we have 101,000 ohms, which will be multiplied by what, we have 1 microfarad. Micro means 6 zeros. Okay, 10 to the power minus 6. 1 2 3 4 5 and then 1. So 1 2 3 4 5 6. Yes, 6. Okay, so after giving everything, okay, I can see that our on time is 0.06 seconds. That means it is not even like a tenth of a second. Okay, so in order to change that, okay, we should increase the capacitance. Okay, So if we change the capacitance, say let's suppose 1, 2, 3, 5. Okay, let's say if we change the capacitance by 10 microfarad instead of 1 microfarad, that might make a very big difference and we will be able to see the blinking. Now let's see. Okay, we can see, right? It is taking approximately 0.69, that means 0.7 seconds to turn on, and a little bit less than that in turn off positions. Okay, so here we have created our very own 555 timer circuit. Okay, and this is in a stable format. A stable, I've already explained. We have two more format, which is called bistable and monostable. Now bistable is kind of like a toggle switch. Okay, you guys know what is a toggle switch, but you have not heard the term maybe. So we have two kind of switches. There are some kind of switches where you push the button, and only for the amount of time you're pushing the button, the LED or the fan is on. When you remove your hand, the thing turns off, right? That is a push button. Then there's a second kind of button which all of us have in our homes. There's a switch, okay, where we can push it. Okay, the best example of a toggle switch is your caps lock. You push the caps lock button of your computer once and its caps lock is on, right? When you push it again, it is off. Similarly, in the bistable mode, there is a push button. Okay, suppose if the output of the 555 timer is at 0, it is 0, then you push, it will become 1 and it will stay 1 until you push it again and make it 0, like this. So it is stable at both states, 0 and 1. Monostable is, it will be stable at either 0 or 1. That means suppose it is stable at 0 and you push it for the amount of time you are pushing the button, it will stay 1. When you remove your hand, after some time it will come down to 0. That means it is stable at 0, but the amount of time you're pushing the button, वो ऊपर जाएगा 1 हो जाएगा and then वापस 0 हो जाएगा. Okay, so I hope you have enjoyed it. I hope you have, I I I know that it is a bit in deep, okay, but isn't that the fun of electronics? That these marvelous things. Suppose this is the size of a 555 IC. This much small thing is able to generate a blinking LED. Okay, we used to do blinking LED. How? Connect Arduino, do that, and then blink our LED, and we can also control it. Okay, we will learn about potentiometers. Okay, some of you who know the potentiometers, we can replace one of these resistors with potentiometers. Okay, using that we can change the frequency, while running we can change the frequency by changing the resistance, right. Okay, so now question for you guys is that if I want to make a flexible 555 circuit, that means I want to be able to changing the frequency. अगर मेरे को frequency change करनी है work run time में, तो मैं वो potentiometer, it's a device which I'm going to use. Okay, तो मैं वो potentiometer कहाँ लगाऊंगा? R1 की जगह पे लगाऊंगा कि R2 की जगह पे लगाऊंगा? Okay, टेल मी. आई विल रिपीट द क्वेश्चन अगेन. अगर मुझे इसको ऐसा बनाना है जिससे मदद से मैं फ्रीक्वेंसी चेंज कर सकूँ 555 टाइमर की, तो मैं वो एक कंपोनेंट यूज़ करूँगा रजिस्टर की जगह, जिसको बोलते हैं वेरिएबल रजिस्टर. ओके, इट्स हैज़ अ नॉब काइंड ऑफ थिंग. ओके, तुम लोग जो यूज़ करते रहोगे ना आप लोग साउंड को इंक्रीज एंड डिक्रीज करने के लिए कंप्यूटर में, दैट इज़ पोटेंशियोमीटर ओनली. सो मैं वो पोटेंशियोमीटर कहाँ लगाऊंगा? R1 की जगह लगाऊंगा कि R2 की जगह लगाऊंगा? ओके, and give answers based on, okay, explanation. Don't just copy others comments. Okay, so answer in the comments. Okay, I hope you have enjoyed it. Okay, so next video we are going to start okay, so everything is good. Next video we're going to start with Arduino. Okay, we will learn about digital write, digital read. Okay, basic commands. We will revise everything again, and we'll also learn about potential divider in the further sessions. Okay, so happy learning. Thank you.